Hi, I'm Roger Gabriel, Sales Director at Mentech Technology USA. Welcome to our booth. We've got a magnetics design case study I think you'll find interesting. I'll introduce it and then pass the baton to our applications engineer, Martin Yin, for the technical details. The case study gives an overview of design considerations that took us over 5 versions of a PFC. A Tier 1 consumer electronics company presented very challenging form factor requirements for a new product that has very specific appearance and industrial design requirements. We proposed CMCs, DMCs, and PFCs, customizing them and optimizing them for over a year as we worked with their R&D, as well as their industrial design and marketing teams, going through several iterations. This case study steps through those iterations with the PFC, examining performance, size, and cost trade-offs to achieve the optimal design. They expect to ship many millions of this product. Now I'll hand this over to our applications engineer, Martin Yin.
The requirements are footprint 35 times 32 millimeters maximum, height 40 millimeters maximum, DCR 200 milliohms maximum, OCL 330 microhenry at DCR at decibel 7.1 amps. RS, the lower the better. The initial design proposal. The coloring means green, okay, meet spec. Yellow means acceptable but prefer better. Red means not acceptable. There was very little PCB space allocated to the PFC inductor, and the height restriction was very challenging at 14 millimeters maximum. Standard PFC was too large on the PCB and too high. Our engineers determined that EFD25 can meet the size requirement, but it could only withstand 7.1 amps decibels due to its small AE. As well, DCR was high due to the winding space is limited, so we have to use a smaller gauge wire. The second version, PQ3220, has much bigger AE, which provided very good decibels performance. It can meet 330 microhenry at 7.1 amps decibels, but it's too large and too high. The third version, as long as the customer needs only 4 pins, we trim the pin shelf to minimize the pin footprint down to 35 times 25 millimeters. The fourth version, we made 3 changes to this version. Changed from traditional constructors, bobbin, wire, cores, to flat coil and cores. It's planar design. It doubled the winding space, but because there is no bobbin in it. 2, changed from EE core to EI core for about reason, because we already have enough winding space. Then we have benefits that it's lower and it's lower cost as well. 3, we changed inboard design, which can minimize the height further from 23 millimeters to 14 millimeters. But the flat wire has higher RS due to skin effect. The production version, we changed from flat wire to multi-strength wire to lower RS. This enabled us to get a very good performance, aligning with all our customers' requirements. Just one slide to mention our R&D and support team. Mentech has 264 R&D engineers spread across Dongguan and Shenzhen locations. They serve new product and process development, as well as supporting projects directly for customer in custom product design. We do many customs. We've got a few suite of in-house test equipment that I want to show here. Vertical integration allows us to modify all aspects of product and gives better control of quality and scheduling. Our high volume manufacturing experience informs design decisions for manufacturability. Mentech has deep magnetic design and the production expertise. We often do customs, and we would ask to be considered for your next project. Please feel free to reach out to our sales and applications contact. Give us a part cross or your specifications, and we will respond with a compelling proposal. We look forward to speaking to you. Thank you.